Okay, class, this is going to be a little demonstration on Lab 4, which is about physical and chemical properties. And I'm going to just take a couple minutes and do the first couple easy parts of the lab. The first one is about measuring mass of ice and water, and I have a little container with a lid with ice, and I'm going to use our balance. And we're going to turn the balance on and place the container of ice on the balance and record the initial weight of the ice and the container. We're going to record that in our data. Then we're going to set this to the side and we're going to measure it again after half the ice is melted. And you'll record the weight. And then at the end, when all the ice is melted, you record the weight a third time. And compare your results and make observations. So this is just a simple way of using your balance, practice using your balance, and noticing how a change in phases, so going from a solid to liquid, what impact that has on mass within the container. And be sure you wipe off any condensation on the outside as your procedure demonstrates. So just give you an idea of how that first part works. The next part, part 2, is called paper experiment. And all you're going to do is take a 1-inch square piece of paper. I have some basically printer paper here I've cut up into a little 1-inch square. Actually, I can make that a little bit smaller. And what I would do is fold it up into kind of a little piece of paper like this. And then you're going to light the top, and then you're going to put it into the beaker and make observations. So this is just an example of how this might work. So you'll light the little piece of paper like this, and then as it gets down to the end, put it in the beaker, and then let it continue to burn, and then you're going to crunch it up and make observations with your stirring rod as to what actually happened with the paper as it burned. Okay? So be sure you don't use too big of a piece of paper, and keep the flame up, and then as it burns down, go ahead and throw it in the beaker, crunch it up, and make observations, okay? So that's pretty much the first couple little experiments. Okay, this next experiment is called a fire extinguisher. And what we need here is a graduated cylinder, a little vinegar, our baking soda, and a scoop, a beaker, and a candle. And what we're going to do is pour 30 mils of the vinegar into a graduated cylinder. So we'll get that up to about 30 mils, about there. And then we'll add the 30 mils to the beaker. Okay. Then we want to light our little candle. Next we add about 2 scoops of baking soda to our vinegar, and once you can make the observations as you go forward as to what happens. So get that fizz a little bit. We'll stir that around, and then we're going to pour the gas onto the calendar, and you see that the calendar goes out, and it's because of the gas generated from the vinegar and the baking soda. So be sure you record all your observations. Okay, this next piece of our next step of the lab is called sand and salt. And what it asks you to do is pour about 30 mils of water into a beaker. So let me get some water here. So we're going to pour 30 mils of water. I'm going to measure that into our graduated cylinder. Rinse that out from we had some vinegar in there from before. So let's take 30 mils. Okay, I'm going to add that to the beaker. Then it says to add a couple scoops of sand and a couple scoops of table salt. So you have sand in your kit. So we'll take this. Open it. So we're going to add 2 scoops of sand. 1, 2. Then we're going to add 2 scoops of table salt. 1, 2. This particular step of the experiment I will demonstrate. You do not have to do yourself. So you just fill in your lab report based on what you're seeing in this video. Okay, so that way you don't have to use the burner, because there's a part of this where you use the burner. So then you mix the sand and the salt and the water, and then we're going to filter this to separate what's in solution and what's dissolved and what's not dissolved. And we're going to do that using a filter paper. So here's your filter paper. And to make your filter paper fit in this funnel, you got your little funnel here. You're going to fold it in quarters like this. You can fold it in quarters like this, and then you place it in the funnel like that. And I've got this on a Erlenmeyer flask. Then we're going to take and pour our liquid through the funnel. And sometimes with help is a stirring rod, just to kind of get it right in the center, and you decant through the filter paper. You'll see that the water starts to run through. There we go. And give that a minute as the water passes through the filter paper and leaves behind the undissolved sand and whatever other material is not dissolved. Okay, let's give that a couple minutes to filter through, and then we'll get ready for the next step, which will be the use of this burner. And you don't have to use the burner. You can just base everything on what you're going to see in my demonstration here. This is the burner I've set up, and there's alcohol in the bottom, and it's wicked up through this little copper loop, and I've got it on a hot surface, on a hot plate, so it's a heat protected surface, and I'm going to light this. There we go. I don't know if you can see the flame, but there is a flame there. There's alcohol that's being wicked up through the copper tubing, and we're going to use this to heat up our test tube when we take what's gone through the filter paper into a test tube. Now be sure this, if you ever use a burner like this, that is very hot, so you want to be careful. Okay, we have our test tube and our test tube rack here. And we're going to wait for this water to pass all the way through. Okay, we see that all the liquid has passed through the filter paper now. So what we will do is take a few drops of our liquid. We're going to use our this is called the Filtrate, and I think it says a couple drops. So I put a few milliliters into the test tube, so a couple mils. So we're going to use our little eyedropper here. We're going to take 1, 2, well, maybe 3 droppers full. Now, so we have our liquid that's passed through the filter, and we're going to hold it over the burner and evaporate the water, and hold it at an angle. You know, if you ever do this yourself, you don't want to point it at your face. This is why you wear your PPE. And we're going to just let this boil a little bit, get it heat with the burner going. Okay, it's starting to boil now a little bit. You see that? Let's do it gently if you were to, so that I don't want any of the liquid to boil out of the top of the test tube. You make your observations. You can see that you also have some steam coming out the top, and you have some bubbles condensing it near the top of the tube before it has a chance to evaporate out the top. We're going to let this boil a little bit and make our observations after we have evaporated off all the liquid. This might take a few minutes. So we know that we have salt dissolved in the liquid and it passed through the paper, and we're going to make some observations after we've evaporated off all the water. Down to the end now a little bit. And I want you to try, if you can, in the calendar. Notice, make your observations of the test tube. And what do you see in the tube now that all the water has been evaporated? Can you see that? So there's just very little water left, and you have white solid on the side, which is the salt that was dissolved. Okay? Okay. We're done with the burner now, so I'm going to put it out. And I'm going to show you this. Now what we're going to do is we're going to put this in the rack to cool a little bit. And then it says, once it cools, so we're going to add a few more drops of water now once it's cooled to see what happens. So we have our little container of water here. We're going to let that cool for a few minutes. And let's just add some water and I'll hold it up so you can see what happens. Any predictions? So you can see that as we add water back to the solid redissolves and the white salt that was on the sides goes back into solution. Okay, so this is just a demonstration of evaporation and dissolution of a salt in water. Okay, so make your observations based on that. Don't worry about doing the burner yourself, just do your observations based on what I've shown you here. Okay, this last part of this lab is called sodium carbonate and cupric sulfate. And what we're going to do is make a couple small solutions in water, one of cupric sulfate and the other one of sodium carbonate. So what we need to do is take a little piece of this blue solid in your kit. This might take a little bit of time to dissolve, but we're going to put it in beaker, just a little piece. Start with that, and then we're going to add 30 mils of water. Where's my water? Let me get some more water. Just use tap water. So we're going to add 30 mils of tap water. So let's measure 30 mils in our graduated cylinder. We're going to add that to the blue cupric sulfate. This might have to break up with your spoon or with your stirring rod to get this. Is going to take a while to dissolve. It's not very soluble. So we'll kind of try and break that up a little bit, let that soak. Maybe tip it and put it in the corner and break it up like this. So you see that this copper salt is not very soluble. So it's going to take a while for it to dissolve. So just take your time in the corner and break it up a little bit. Even though you still have some glue in the bottom, there's some that is being dissolved and going into solution. So we'll let that soak a little bit. Now we're going to take a little bit of our sodium carbonate, right? Yeah. So just a small amount, pea size it says. So that's not very much. So I would say something like that. That's pea size. We're going to put it in the other beaker. And then we're going to add 30 mils of water to it. So we'll take our graduated cylinder. And we'll measure about 30 mils of water. There we go. And we're going to add that to the sodium carbonate. Okay. And then we're going to stir this. I'll use the other end. Okay, and that dissolves much easier than the copper sulfate. Actually, you can see how this is dissolved because it actually is turning blue. So we know that we're getting some of it dissolved. So let's break it up a little bit more. you don't have to dissolve all the copper sulfate, but you do want to be sure at least that your solution in this beaker is blue, so you know that some of it has been dissolved and is in solution. So we'll just kind of mix that up and dissolve it a little. Give it a couple more minutes. Okay, now what we're going to do is mix the two solutions in a test tube. So it says 1 to 2 mils of copper sulfate and then add the sodium carbonate. Shake gently and record your results. So we're going to let's just take 1 drop for now. 1 dropper of the copper sulfate. And then we're going to add 1 drop of the sodium carbonate, and we're going to watch what happens. Okay, I don't know if you can see that, but you can make your observations. You can actually do this experiment. It actually is getting cloudy. Might be some bubbles coming off. Let's try adding a little bit more of our sodium carbonate. Okay. Let's try a little more of this. So, I'm not going to tell you everything that's going on here right now. I want you to make your observations and make some hypotheses of what could be going on when you mix the two. Be patient when you mix the cupric sulfate. The more you can get in solution, so just take your time and take 1 dropper or 2 droppers of copper sulfate, add 2 droppers of the sodium carbonate, and make your observations, and we'll go from there. Okay? So you get the initial appearance of both, and then observations after mixing. Okay? So again, just a reminder for this lab, don't worry about the alcohol burner. I've demonstrated how that works and make observations from this video. That way you don't have to worry about lighting the burner in your homes and having an open flame and worrying about that. So make as much observations as best you can from this video. The other parts you should be able to do yourself, make your observations and make your hypotheses, and we'll go from there. Okay? Hope this helps.